Okay, so today we're going to be talking about rational equations. So what do you think of when you hear the word rational? All you got to think about is rational just simply means the word fraction. It's kind of basically the same thing. So we're talking about an equation that has a fraction in it. That's what we're talking about. So here's an example of an equation. We're trying to solve for this. Keep in mind at the end of the day you might really benefit from checking your work. Also just plug everything back in, make sure you still end up with a true statement. So how do we do this? The best way to deal with these is we're going to actually try to clear all fractions. That's going to be our main goal for these equations, right? And what I mean by that is you're going to try to get rid of all the fractions by multiplying everything by the LCD. So both sides of that equal sign, okay? So in this case, you're looking at your fractions and I've got a 3 and a 2 on my denominator. Well, that means my LCD must be 6. So because my LCD is 6, I'm going to multiply each fraction by 6. Now, technically, it's a 6 over 1 if you want to keep that there, if that makes more sense to you, to keep it all as fractions, but that's up to you. I'm going to leave that, guys, completely up to you. And then what you'll notice is that each fraction separately will have something that cancels. So this first fraction, that 3 and that 6 will turn into a 2. This 2 and that 6 will turn into a 3. And then 0 times 6, that has no fractions. So that's a little bit simpler. Okay. All right, so now let's see, what have we left over with? What have we got left? If you'll notice again, like I said, each fraction had something that cancels. I still have this x minus 8 there. Okay, so I still have that. So what I've ended up with, and let me actually give myself some space. Okay, what I end up with now is I just have the 2 left over from right there, and then I have that 2, and I still have the x minus 8. I still have this plus sign, you can't forget that, and now I have a 3 and an x minus 3 equals, and then 0 times 6, of course, is just 0. And what we've done is we've gotten rid of the fraction, so it's much easier to solve. Distribute, combine like terms, get everything, get all the x's on one side, the numbers on the other. Okay, so I ended up with 5x minus 25 equals 0. I've run out of space, I apologize. So 5x minus 25 equals 0. Add 25 to both sides. And you'll end up with x equals 5. Okay, and again, go back and plug it in to check to make sure it worked, and use your calculator if you need. So that's how we solve these rational equations. Now, of course, that can get a lot more tricky. So let me go ahead and do a more difficult problem. And it's still, again, it's going to say solve. So let's do the one that has a 2 over, let's do x squared minus 9. Oops, that's a 9, sorry. Plus 5 over x minus 3 equals 3 over x plus 3. So let's do that as our problem. So here what we're going to do is we have to make sure we know what the LCD is. And the only way to really know what that LCD is to make sure all of your denominators are factored. So that's the first thing that you want to do, is factor all of your denominators. And once you'll notice from there, I can see right away that my LCD has to have the x minus 3 and the x plus 3, and you'll notice that that contains all of the denominators. So that's what our LCD is. So what you're going to do is you're going to take that LCD and you're going to multiply it, okay, to all fractions. So I have x minus 3, x plus 3, x minus 3, x plus 3, x minus 3, x plus 3. Okay, and then each fraction separately is going to have something that cancels. So this first fraction, it looks like the entire denominator canceled. The second fraction, the entire denominator, that x minus 3, canceled with this x minus 3. Over here, this third fraction, that x plus 3, canceled with this x plus 3. And then let's see what we're left over with. This first fraction, notice the only thing we were left over with was the 2. Plus the second fraction, notice I still had that 5. And then I still had this parentheses and the x plus 3. Don't forget that that stayed there. That was my x plus 3. And then I have my equal sign. And now here I still have this x minus 3. So I have this 3 from out front. Okay, and then I have the x minus 3. And then from here, again, combine like terms, simplify, and see what you can do to solve. Okay, so I went ahead and solved that. I ended up with x equals negative 13. Go back and look at your original problem, use your calculator, plug it in, make sure that you get a true statement. Let's go ahead and do one more, one that's a little bit more complicated. It's still going to be the same directions. I'm still going to ask you to solve this guy. So let's solve one that looks a little bit trickier. So 1 over x minus 6 minus 1 over x equals, equals 6 over x squared minus 6x. Again, in order to solve this, we need to make sure everything is factored first. So you look at the denominators, and the one that needs to be factored, you factor that one first. Notice that x squared minus 6x, that had an x in common, so I could factor out that x. And then I can notice from there that my LCD must have an x and an x minus 6. It looks like that takes care of all three denominators. Okay, so once I have my LCD, one more time, multiply all three fractions by that LCD. And then each one separately will have something that cancels. So the x minus 6 canceled there, and I was left over with just a 1 and an x, minus the x canceled here, and I was left over with just a 1 and an x minus 6. Here the x canceled and the x minus 6 canceled, so I was left over with just a 6. Okay, and then again, let's go ahead and solve that. So I'm going to go ahead and simplify that. I ran out of space. Again, let me go over here. So this was a 1x minus a 1x minus 6 equals 6. Yeah. Let's combine like terms. So this is an x minus x plus 6. What I did is I went ahead and distributed that negative. X minus x go away, and I got 6 equals 6. What does that mean when 6 equals 6? So here, what we got there is we got a true statement. So because it's true, this is all real numbers except for, you must go back, and this is the part where you got to be really careful, look at the original. Do not plug in 0 in the denominator. I can't plug in 6 because that would make this denominator 0. I can't plug in 0 because that would make this denominator equal to 0. So except for, oops, let me get the red, x cannot equal to 6 and x cannot equal to 0. Alright, so that's the solution right here, all real numbers, so long as x does not equal 6 and x does not equal 0. So sometimes you get a true statement, and that means all the numbers work. Sometimes you'll get two answers where only one of them will give you a correct solution. So you just got to be careful, pay attention to each one along the way.